Alright everybody, Mr. B is back with another video, ready to talk about plate tectonics, the final section in our unit. And so in our image here, you can see that there are different plates that exist, and we're going to talk about how that fits together with the movement. Let's take a look at our notes. Alright, so the theory of plate tectonics. This idea was developed by a Canadian scientist. Tuzo Wilson observed that there are going to be cracks in the continents that are similar to those on the ocean floor. And Wilson proposed the idea that our lithosphere, which remember is in the mantle, is broken into separate sections called plates. The plates fit together along the cracks in the lithosphere. So essentially all these cracks are going to be making up what we would consider to be our plates. And the plates are going to carry the continents or parts of the ocean floor. And we talked about that a little bit with our idea of seafloor spreading. Wilson combined what geologists knew about seafloor spreading. We talked about the evidence of seafloor spreading. And so Earth's plates and continental drift into one single theory. And his scientific theory, which is considered to be a well-tested concept that explains a wide range of observations. So let's take a look at what he considered to be this idea of plate tectonics. Here's what he thought. He thought that the plate tectonics are pieces of Earth's lithosphere that are in slow, constant motion driven by convection currents in the mantle. And we talked about convection currents earlier this year, but we also talked about it when you were doing your seafloor spreading project. The idea that you have this magma turning to molten material that's coming up, and it's spreading and causing our seafloor to change in the subduction process, and then it gets recycled and started back up again. The theory of plate tectonics explains the formation, movement, and subduction of Earth's plates. And so this was thought of as the movement of current plates in the mantle. That's a major force that causes plate motion. So this idea is essentially why our continents were grouped together at one point in time and have been slowly moving apart. During subduction, gravity pulls one edge of a plate down into the mantle. Alright, so that's where we get that subduction, where we have the continent or the seafloor that eventually gets subducted down, or the oceanic crust gets subducted down into the mantle, heated back up. As the plates collide, they move, pull apart, or grind past each other, producing changes in Earth's surface. When this happens, it creates things like volcanoes, mountain ranges, and deep ocean trenches. So that helps to explain why we have trenches, mountain ranges, and volcanoes that are found within the ocean floor. And then also when we get into our earthquake unit and volcano unit, you'll see that that effect also is what causes them on land versus in the water. Alright, so plate boundaries are edges of plates that meet at the plate boundaries. Now, you're familiar with plate boundaries because when you were doing the activity of the puzzle pieces, you had to kind of line up the plates together to try to make them fit. We use the word faults to describe breaks in Earth's crust where rock has slipped past each other to form these boundaries. Now, scientists have used things like satellites as instruments to help understand and measure the plates. This has become very precise. The plates are moving very slow. All right, some of you had asked the question, well, are they eventually going to collide with each other? Well, they've been drifting very, very slow. In fact, it's 1 to 24 centimeters a year. Right? So that's a very small amount. So it's going to take a long time before that happens. The North American plate is moving at a rate of 2.5 centimeters per year. So think of what a centimeter is, and it's moving only 2.5 centimeters a year, and we are obviously on the North American plate. Alright, so we get into the idea of what's called a divergent boundary. That's the place where two plates move apart or diverge. Right, so you can see in the image here, you have one plate pulling away, one plate pulling away, and it creates this area. Most occur along mid-ocean ridges where seafloor spreading occurs. Divergent boundaries also occur on land. Alright, so you can see that here is an example of that. And that example is going to be the Great Rift Valley in East Africa. These divergent boundaries occur when two plates slide past one another. Another type of movement is what we call convergent boundaries, the place where two plates come together or converge. When two plates converge, the result is a collision. So essentially you have a plate and a plate, and as they come together, they collide with one another. Density determines which one comes out on top, so one is going to get forced down, the other one is going to go up above. That process is called subduction, an example of this in the water. So we've talked about that with our seafloor spreading. When you have the plate that gets shoved down into the mantle, that's an example of subduction. Mountain ranges are a result of two continental crusts colliding. So when you have the one going down and the other one getting forced upward, it creates that mountain range. And so you can see the example here where the one gets shoved upward and it creates the mountain range, the other one is forced back down into the lithosphere and asthenosphere. And then the same thing can hold true for creating a volcano. Another one is the transform boundaries. This is where two plates are going to slip past each other and they're going to move in the opposite direction. So before we saw that they pull away or they collide with each other. These two are just sliding and moving past each other, and as they do that, it is going to result in an earthquake. And so this is what the plates have looked like over time. This should look similar to what we did with our activity, where essentially we had all the plates clustered together, and you can see that they look different. All right, at one point in time they were grouped together. They've been slowly drifting apart due to that seafloor spreading, and now this is how they look. That idea is called Pangea. All right, so there's evidence that Pangea existed and that all the continents have split apart billions of years from what was called a supercontinent. So here is the example of the supercontinent, also known as Pangea, and they have been drifting slowly over the years. All right, so that is section number 4. Make sure that you take a look at this video and ask any questions that you have. That'll finish it up. So we've talked about Earth's interior, we've talked about seafloor spreading, we've talked about the idea of continental drift, and now the theory of plate tectonics. Alright, so keep looking over these videos, and we'll talk to you soon.